Hello guys, in this video I'll show you how to find the gravity in the Super Mario's world. Have you ever wondered the gravity in Super Mario's world is different from us? Let's try to find out the value of it. So obviously the first thing that you need to do is to download the video from say YouTube so that you can use the software to analyze it later on, no matter you use Tracker or Vernier Logger Pro. And here is a website that I've been using for many years for downloading YouTube videos. I'll put a link in the description below. After you download the video, obviously you need to open the video according to where you download in the Tracker software. Notice that the video that you choose, if it is really long, then will take a long time to set up in the software. So I would suggest you to choose as short as possible, or you can try to crop it first before you import to the software. So the next thing that you want to do is to scan through the video and try to find a motion that is suitable for you to analyze. Since you're finding gravity, so the motion of maybe knocking the brick may not be suitable for you. So you need to take some time and try to see if there is any easy or nice, like which is something that you hope Mario will jump for a longer distance. Actually this one looks pretty good, and therefore you can reduce the percentage error in that case. So try to find a motion that is rather long. I think just now that one is pretty good, so I'll go with that one. Okay, so I'll rewind back to certain frame. I think this one may be good. Okay, some may argue that hey, so maybe it's different kind of initial velocity, but it doesn't really matter, because ultimately when you find the acceleration in the mid-air, that's simply is the gravity. So we can just start with this, and I'll choose like what we practiced with the first video. If you haven't watched it, go and watch it now. So using this create and with the shift button, you can choose the first point. So I think for simplicity and consistency, I would choose is head, probably, like the highest point. One thing that I find out is you can see now it kind of having two shadow. I don't know why, but then it's kind of having two character that overlap. So I would try to choose maybe the middle. And sometimes this happen also in, even if you're doing a practical experiment in real life, your camera shutter may not be short enough to capture the motion. And therefore you have a long exposure. Okay, so since it's almost touching the ground, so I will negate it and I'll just stop here, because obviously it will decelerate when it hits the ground. So I'll stop here. So from what I see here, then I can try to study like what we did earlier. This is X, so we don't actually care about horizontal, we just want to see the vertical. So it's a pretty nice parabolic curve you can see here, and we will want to actually study the previous. So I think the most important thing is go to analyze it, and like what we do earlier, we want to use a curve fit, but then we actually don't care about the point at the front. So you can actually select. So just like just now what I did, I used left click to select the point that I care about. Otherwise the program will just think that you want to analyze all the points and try to find a fit to it, which will not be successful if you want to fit a linear line into this obviously curve. So I would choose maybe around these, and so it's actually a pretty good linear line, and from that you can generate a line, and that is with a certain value. But in fact this is not done yet, because again I forget to set the reference for the length. So you may ask, so how can we set up that then? One thing that you want to do is to find the height of Mario And according to Google, well, I just simply assume this is correct. Then it is 155 cm. I suppose this is when he ate the mushroom, I think. So back here, what I need to do is I have to set the length from, say, can I actually set for another more clear? I think this one probably is better. Yeah, here. Okay, so from this point to this point. Oops, I didn't do it very well. Okay, I can actually readjust it. Okay, and is this fair enough? Okay, let's take a look. A little more, I guess. So I would want to change a little bit more, and also you want to make sure it is vertical to the ground. I think this is pretty good. The good thing about pixelize is you can literally adjust the pixel. Okay, so here what I guess should be, I forgot again, 155 cm. So it's in meters, so 1.55 meter. And so everything should be okay. Just to be safe, I will refresh the whole thing, and again I will analyze it again, and I've selected all the points already. And so from this I can get the equation with the slope of negative 126.6, because it's E1, right? So 10 to the power of 1. So it's actually negative 12.6. So that is to say the world in Mario will be slightly higher than the one on Earth. But then I try to cross-check with this guy who also make a video on gravity of the Super Mario World, and I can find his answer is a bit different. Well, it's actually a lot different from mine. His final is actually 78 meters per second square. And therefore, what I try to do is I will try to go back to the tracker, try to find some other point, some other jumps that I will try to evaluate the acceleration as well. And here is some results that I find out. So other than just now the A, that one that I try, I also try B, which of course still Mario, but then another path. Somehow the path is very strange. I can't even think this is falling freely in gravity. And so I will simply negate that. I don't think this is useful. And I also find another one. Somehow the velocity time graph vertically is not very smooth. And so what I have to do is I have to select the point so that it kind of show the general trend of it. And as you can see here, from the slope here, which apparently represents the acceleration due to gravity, is around negative 53. And I also try with another path, which I also get a similar result, which is around negative 54. So I think the first one that I did, I have no idea, but somehow this is a bit different. So maybe I should try to do one or two more of the trial. And also the reason why my result is different from his result is probably because of just simply it's different generation. So you can see the one that he tried was more like using, I don't know what, I think this is like generation 3 or something. So it might be different gravity because it's simply just different game. Also, it could be the methodology also. I will leave the link in the description. The way that he did, instead of using video analysis, he will try to calculate, I should say measure, the time that it takes falling from the top to the bottom. And in a way, if you're using kinematics equation, you can actually calculate it also. So this is another approach that you can do. And you can try to do the same thing actually with the same video and see whether which one is more reliable, or would they be giving the same result. Since I tried many times and I still don't find a very stable value, and I suspect whether it's probably the the source of the video, maybe the frame per second, is not very stable. And so what I do is I go online and find a simulator where you can run the game again. So I'll just try to take the video by myself, and I'll try to enlarge it so that it will be of a higher precision, and I'll put this video into the tracker. So I have imported the video into the tracker software, and I also selected the scale according to the height of the Mario. So let's start to do the tracking using the same approach. Wow. Okay, so let's take a look of our results and analyze it. Okay, so we have the VT graph, yes, and we'll want to know the curve, which I think this one, or like mainly here, will be still around negative 45, so negative 45 or 46, quite coincide with what we find in the later trials, that is 50, around negative 50. The reason why I want you to try using video analysis 2 for a non-physical world like in the video game is I want to show you that actually like all the games, well, not all actually, most of the games that you play, especially action games, they also required a certain sort of a physical engine. So this company or this tool is called the Unreal Engine. It's one of the very famous tool that helps you to build physics. So think about this. In the past, when people have to make a game like Super Mario's, the programmer try to create the physical world by themselves. Of course, they can do something that doesn't really obey the physics law, but then if everyone have to do this from scratch, then that would take so long time. So and that's why there is some sort of developing tool called the Unreal Engine, or of course there are some other types as well, which will be widely used by some companies. And when they try to develop their games, they can rather focus on maybe the game style, the story, the graphics, rather than the physics itself. So it's much easier to develop. And at the end of the day, what I'm trying to say as well is learning physics is not necessarily only leading you to be a physicist or engineer. It could actually help you to do something like this as well. So one day maybe you'll be using physics not for building bridges or research, but maybe for developing amazing games like this one called the Portal 2, which you'll see amazing physics result if you allow certain things to happen. So I would like to challenge you to see if you can find out a certain gravity of the game that you play, and let me know if you think that is sensible or not according to the way that you calculate. And feel free to comment your finding in the comment section, and I'll see you again next time.